Hello and welcome back to Calculus, the series where we explore derivatives, integrals, and their applications. First, I'd like to thank all the nice people that support this channel by liking and subscribing. It helps massively for me to make more videos for you to enjoy. As promised, today we begin learning how to apply the theory we've learned so far to actually finding some stuff. And the first thing I'd like to show you is how to find the area under a curve. You might remember from part 14 when I introduced integration, I gave a visualization of how integrals sum up the areas of infinitely thinner rectangles that can be used to represent the curved area under a curve. After that, I explained that in order to find the value of the area, which is a real number, we have to use a definite integral, where the bounds of the integral correspond to the bounds of the area. If you have no recollection of this, check out the first 4 minutes of part 14, integration. So now let's dive into an example to see the steps to take which lead to finding the area under a curve. Let's say we are given a function f of x equals to 2 minus x minus 2x squared plus x cubed, and we're tasked with finding the area under the curve. First, let's immediately put this on a graph. Visualizing this, we can see that there are two areas here, one above the x-axis and one below. Please note that when we speak about area under the curve, we do not mean everything that is completely under the curve. It just means the area that is bounded by the function and the x-axis. Okay, so now that we have the function visualized, what we need are the bounds of the integral. In our case, we would actually have three different bounds, because the bounds here are simply where the function and the x-axis intersect. In this case, point A, point B, and point C. Now, at these 3 points, the y value is going to be 0, meaning to find them, we can actually take our function equated to 0 and solve for x. Next, I factorized our cubic function, equated it to 0, and the 3 values of x come out automatically. So now that means in order to find this area right here, I need to calculate an integral from -1 to 1, and then to find this area right here, I need to compute an integral from 1 to 2 of our function f of x, and we can add these two areas together. At this point, calculating these two definite integrals should be really easy for you. However, a question you might be asking would be, why not just construct an integral from -1 all the way until 2 of our function f of x? The answer would be, the area that is under the x-axis is technically negative. It means when calculating this integral from 1 to 2, the value you're going to get is a -1. So that means when you compute this area upper part, and then you're going to be subtracting the area of the bottom part, not adding it, meaning the answer you're going to get is incorrect, which is why it is extremely crucial that for the negative parts of the area, we have to put absolute value signs. Computing this integral will give you a negative value. However, the absolute value signs will turn it positive. And then the answer you're going to get is this integral or this area plus this area, which gives you the total area. For those of you curious, the answer here is 37/12. However, now you might have another concern. Sometimes there are more complex functions and we do not have a calculator or graphing program to see which part of the area is negative. In this case, just to make sure that you are not subtracting any part of the area, what you can do is put the absolute value signs inside of the integral. Again, using that same example and same function, let's once again visualize what does the absolute value sign do to our function and area. What happens graphically is that everything that is under the curve is now translated upwards. So that means this part of the graph that is below the x-axis is now going to be going outwards. Now, this also means that area can now be computed as one single integral instead of two. You can just set an integral from -1 all the way until 2 of our function f of x in absolute value brackets. And the answer that you should get should be the same, 37/12. Here, I will conclude the basics of areas under the curve bounded by one function and the x-axis. In the next video, we will speak about area bounded by two curves or by two curves and the x-axis. So, I hope to see you there and have a nice day. Bye!